Hello, everyone. Thank you for the introduction and the opportunity. So I'm going to talk about DNS root servers and more specifically, maybe a couple of reasons to run a local copy of the root zone in the recursive resolver. So here is a brief summary of current state of DNS root servers. The access time or the round trip time to the root servers is primarily dependent on a couple of factors. One of that is availability of the root server instance within the country, and the second is optimal routing. From a resiliency, from a security point of view, transactions between the recursive resolvers and the root servers are not encrypted. So you have DOT and DOH, which is primarily encrypting the communication between the client and the recursive resolver. From a resiliency and availability perspective, usage of for mitigation, from primarily mitigation of DDoS or distributed denial of service attacks, you have IP Anycast, which is being used. So we have 13 root servers and 12 root server operators and 1086 instances of the root server in different parts of the world. So the broader question that I am posing today is since the root server infrastructure does not penalize abuse, should we continue abusing it? And ICANN-OCTO, which is Office of the CTO, did a study sometime back in April looking at traffic patterns to the root server. So ICANN is one of the root server operators managing the Lroot server. And they looked at traffic patterns more specifically to instances, a few of the instances located in France. And one of the observations looking at the traffic patterns was the volume of junk queries to the root. And the Chromium-based browsers, more specifically, apologies, Chromium-based browsers ideally consumed roughly 1/3 of the volume of junk traffic to the root. So for people who might not know, Chromium-based browsers send a random string, which is 7 to 15 characters each time on startup. And apparently they do this primarily to check if there is a captive portal in the network. Apart from that, there was a significant increase in other non-existent domains as well. So I would highly urge everyone to look at the paper which ICANN-OCTO has published. There is a link to the paper in my slides in the references section in the slides, and the slides have already been uploaded on the event page. From an access to the root server perspective, here is a traceroute from AS9498 to the iRoot server. So NetNod is the root server operator, which has a Anycast instance in Mumbai. And as you can rightly see with regards to the traceroute, traffic is transiting outside India. Here is another example from AS9498 to K-root server, where the root server operator is RIPE NCC, and they have a couple of instances of the root server in Mumbai as well as in Noida. And here again, you see that traffic is transiting outside India as well. Here is another traceroute from AS9829 towards the iRoot server, which is managed by NetNod. And they have a global instance at Mumbai, but again, traffic seems to be transiting outside India as well. Here is one more, probably I'll just skip this one. By the way, the traceroutes as well as the screenshots are from the RIPE Atlas project, which is by the RIPE NCC. So if you're not already hosting a probe, I would highly urge you to look into the project as well as host a probe. If you have any questions regarding that, feel free to reach out to me. So the solution is, a possible solution is RFC 8806, which is running a root server local to a resolver. So the goal of RFC 8806 is primarily to prevent snooping of queries sent to the root. Apart from that, decreasing the access time to the root servers. Faster negative responses, so eliminating the junk queries that are being sent to the root at this point of time. Increase the resiliency of the root server system. Reduce the attack surface as less DNS transactions would traverse from the network, and privacy, that is hide queries which are being sent to the root. From an operational point of view, run an up-to-date root zone server on the same host, such as on the loopback or in the resolver software. So the recursive resolver would use that as the upstream for the root zone. The recursive resolver will also use DNSSEC to validate the responses from the local instance of the root running on the resolver system. So here is a list of all the root servers which currently provide an option to do a zone transfer of the root zone. And one can manually run a command using dig to get a local copy of the root zone. Latest versions of bind have an option to basically pull the root zone in a mechanism called as slaving of the root zone, which is something that is also possible. Having said that, here is an interesting project which is Localroot. So ideally, Localroot is like but not equal to RFC 8806 because it does a lot of other things as well. And the project is by Wes Hardikar from the University of Southern California and ISI. So the goal or the idea is similar to RFC 8806, which is have a local copy of the root zone running on the resolver. It uses tsig primarily to get the zone from the local root servers. DNS notifications whenever there is a change to the root zone. The root zone data is DNSSEC signed and is cached. And there is configuration which is available for bind, unbound, as well as NSD at this point of time. And one of the other goals of Localroot is primarily also to speed up DNS resolution. So let's run a root server from home and serve root. Ideally, I would have loved to do a demo, but presenting virtually has its own set of challenges, and I didn't want to upset the demo gods. So what I have instead for you is screenshots instead of a demo. So the URL is localroot.isi.edu, and one can basically create an account. And once an account is created, you need to create something called as a tsig key. Once the tsig key is generated, what has to be done is you have to create a server where you have to provide the IP address of the recursive resolver that you have running for that matter. And then what it does is then you have something called as a configuration generator, and the configuration generator ideally provides the configuration which you can plug into your local resolver. What can possibly go wrong? One more element in the DNS infrastructure. And if the content of the root zone cannot be refreshed before the expiry time, then the server must return serve fail for all the queries. Having said that, let me also point this out that this was very true in the case of RFC 7706, which has been made obsolete. So RFC 8806 provides an option where if the answer or if the local root server is unable to fetch the latest data from the, let's say, local root in this case, then the resolver can shift to remote root servers as well. So that is something that has been updated. The other change which was very specifically explicitly required in the case of RFC 7706 was the element of running the root server instance on loopback, and that is something that has been eliminated. So now you could run instance, not specifically on loopback, and it may not be explicitly be an authoritative server for that matter. Here are the references to different resources which I have mentioned, and I would be happy to answer any questions that there might be.
Thank you. We got one question so far from Ben Ward. I don't know if I've understood this properly. Aren't there major security issues if you're running a root server? How is it verified?
Aren't there majority security issues if you're running a root server? So technically what you're doing is you're running a local copy of the root zone. So the recursive resolver is ideally looking at the root server infrastructure to pull the information about the roots, about the root zone information which is present in the root zone for that matter. So what RFC 8806 does or says is you can run a copy of the root zone locally on the resolver. And the advantages of doing this is primarily to decrease the access time, as well as the other benefits which I've mentioned. From a security point of view, you're using tsig, which is basically the mechanism with which you are having a zone transfer between the root server or the local root project, as well as your resolver for that matter. Apart from that, I think there is no difference in the previous architecture of how the recursive resolver sends a query to the root. Instead of sending it to the upstream root, it is going to send it locally. So from a security point of view, I typically do not see any issues there per se. Plus, there is DNSSEC that is being used to validate the response between the resolver, the validating resolver, and the instance of the root server which is running locally.
Just to follow up on that one, Ben was asking, so can the root zone be tampered with after syncing?
The root zone cannot be tampered per se because the root zone is DNSSEC signed. So in this case, DNSSEC, the validating resolver will use the upstream which is running locally and be validating using DNSSEC. I hope that answers the question.
Okay, we've got another question from Q Messel from AS207960. And his question was, how are the resolvers pointed at the new root server?
How are the resolvers pointing at the root? So there is a specific configuration. If I can quickly probably share the screen, if you're able to see the browser window that I have open. So if you look at the server section for that matter, and if you go to get config, so what you have is you have the option where you are specifying the root servers as a zone where you have the list of all the root servers for that matter.
Okay, next question is from David Malone. Do people suggest taking copies of any other zones? I keep in-address.arpa and a few others.
Sorry, I didn't catch that question. Can you come again?
It's, do people suggest keeping copies of any other zones?
Do people suggest keeping copies of any other zones? In fact, the Localroot project provides, apart from the root zone, it also provides option for slaving of other zones, as you can see, which is the ARPA zone, as well as root-servers.net and dnssec-tools.org. So yes, that's provided. That's available as well.
Okay, Robert McKay asks, why do we need to create an account on localroot.isi.edu?
Okay, so you could slave the root zone, as available in the latest version of Bind. But a few of the things which it does not provide is it does not provide DNS notify for that matter. So if the root zone changes, you're not getting notified for that matter. That is one. Number two is configuration changes with regards to the upstream is something that is also not available at this point of time. But apart from that, the Localroot project provides TSIG as a benefit for transferring the zone onto your local resolver. That is one of the major security benefits because, from a security point of view, when you're slaving the zone at that point, the zone is typically getting transferred in clear text. There's no any kind of security in place there. So that would be a couple of reasons to use the Localroot project. And apart from that, the RFC 8806 also refers to the Localroot project. So for people or resolver operators wanting to implement this, Localroot is something that is explicitly given as an example as well.
Okay, I think we have time for one more question from Joe Abley.
Okay, Joe Abley asks, the root servers today have possibly more redundancy and capacity than any other parts of the whole DNS system. There are also servers that most resolvers only consult only occasionally. The root server system has never been unavailable ever in the history of DNS. In your opinion, what are the key benefits of putting extra work into making the root zone available compared to the other parts of the system?
That's an excellent question, Joe. I actually remember of one specific attack, if I'm not mistaken, which was maybe a denial of service attack on the root server where few instances of the root server were not available. So it's not the entire root server system, but few instances of the root server depending on the geography. But having said that, I think apart from faster access time to the root server. The other benefits are also negative responses to junk queries. And looking at the ICANN-OCTO study, for that matter, the number of queries, junk queries that are being sent to the root server system is also something that needs to be considered from a community perspective. So the other benefit is also not sending junk queries to the root server.
Okay, I think that's all the questions. Thank you, Swapneel, for your talk.
Thank you so much.